Hi everyone. For some time now, I have been trying to build a system that can read the grid drawings for my project. I even asked people online for help, but nothing really worked out. And after months of trial and error, I finally managed to make it work. At first, this problem might seem simple, or you might think, why build a whole pipeline when AI models like GPT or the Claude AI can already look at an image and tell you the grid size? That's exactly what I thought too, but trust me, I tried this many times and it does not work reliably. If the grid is clean, straight, and generated by a computer, finding its size is easy. But the problem becomes much harder with the real world grid drawings. Lines can be broken, uneven, noisy, or affected by shadows. That's when I realized this problem needs a much more structured and reliable approach. I tried different ideas, experimented with AI-based solutions, and then asked advice from different people on social media platforms like Reddit, Twitter, etc. Their feedback helped me understand why AI models fail in this case and how to design a better solution. That process led to the pipeline I'm going to explain next. The goal is to automatically detect the grid size like rows and columns from the real-world images of hand-drawn or printed grids. When I was gathering the advice from multiple computer vision and machine learning communities on different social media platforms, their feedback was practical and based on their real experience. And here are the short summary that I got from their comments: that vision language models can rely on pattern matching, not on true geometric understanding, which makes them unreliable on noisy real-world grids. The most important step here in this case is to detect the outer boundary of the grid first, and then once the boundary is known, the grid can be rectified to remove the perspective distortion. And after rectification, only lines parallel to the outer boundary should be considered. Human-like heuristics such as merging similar lines, rejecting the outliers, and scoring the candidates works better than naive line counting. And what's the final idea? Detect the outer boundary, then rectify the grid, and then find the parallel, horizontal, and vertical lines to the outer grid, and then count those number of vertical and horizontal lines to detect the right amount of rows and columns inside the grid. So how our pipeline works? We are having three important stages in this pipeline. First is camera scanner that gives us the real-time feedback about the picture of the image. And then comes the cropping and perspective correction to remove the extra part from the image because we're just interested in the grid. And then comes the grid detection that tells us the size of the grid. So for example, here we are having the image of our grid, whether it contains a lot of extra things that we are not interested in. We are just interested in this grid. After passing it from the pipeline, this is our final grid. For example, having 9 columns and 8 rows. So how does the camera scanner works? Camera scanner just captures a high quality image of the grid under real world conditions, because sometimes the image is blurry. Sometimes we didn't know that whether we are capturing it from the right angle or no. So that's where the camera scanner helps us. It tells us the live camera feed, the lighting is correct, or is the focus is sharp enough to detect the grid size. So in short, it gives us like user feedback by making some green boundary overlay on the grid and telling the user that yeah, it's the right time to capture the image. And then after capturing the image, there comes the cropping and perspective correction. How it works, it tells us that whether we need to crop the image or no, because sometimes the image is so much focused on the grid that we didn't need to crop the image. But if it's having some extra background, then we need to crop the image. For example, here we needed to crop the image. And how does this cropping and perspective correction works? We do the image pre-processing, that loading the image in the color form and then converting it to the grayscale for processing, and then applying the Gaussian blur to reduce the noise and removing the extra things like the texture of the paper. So for example, after converting it to grayscale, this is how it looks like. And then there comes the edge detection, the canny part. to detect the corners of the grid, like in this paper, where is our grid located. And this is like a canary detection algorithm that detects the sharp intensity. For example, where we have the grid lines, for example, if our paper is white, then the grid will be like drawn with some pencil and it will be dark. And we will do the edge detection, and then after doing the edge detection, we get the binary image. White one will be our edges and black one will be our background. For example, here, after applying the canny edge detection, we are getting the binary image, black and white. And then comes the morphological closing, closing the small gaps in the detected edges, connecting the broken lines if our grid is broken. For example, here we made out, so as you can see, like here, our grid is more prominent as compared to before. And then we apply the contour detection to detect the boundary of the grid and making the outer boundary of the grid. For example, here we are getting the outer boundary of the grid, and then we apply the smart contouring and then the contouring scoring system that will make the close square based boundary on the image. Like here, after applying those things, we have made the 4 vertices like this to detect the grid, and then applying the perspective correction for the grid detection thing. And this is our final image after applying all the things of the cropping and perspective correction. And after getting the image from our cropping, we can move on to the grid detection thing, applying those same things, the pre-processing things for the grid detection system, pre-processing things, converting it to grayscale, and then converting it to binary image by applying morphological closing, and we got the binary image of our image. And then we made the one big blob of the image to detect the grid, because there are some small blobs inside this image, but we are interested in just the one outer boundary of the image. And after getting the outer boundary, as you can see, we got the outer boundary here, and then we will be moving on to the parallel lines of the outer boundary, like the horizontal lines that are parallel to outer boundary and the vertical lines parallel to the outer boundary. For that, we will use the morphological opening. For example, we are making some kernel, for example, having the height of 50 and the width of just 1. So this way we will be like seeing which lines are parallel to our outer boundary, and then applying the different algorithms or different things. For example, the coverage filter, removing the duplicate lines, and this is our result. For example, these lines that are parallel or that are like the horizontal lines, we are making the outline of these lines. And we are also getting some small lines because of the content inside the cells, but we don't consider them, as these are not the parallel or as these are not the horizontal lines of our grid. We are just interested in the lines that are completely parallel to our outer boundary. For example, here, as you can see this graph, these lines are small, but we have made some threshold that we will be considering just the lines that are these much long. So this is how we can get the horizontal lines. And applying or doing the same process for the vertical lines, we will get these results, and then applying the threshold, we are getting our vertical lines of the grid. For example, this line having some reaching to the our fixed made threshold, we will be considering those lines. And what are the key takeaways from this? We're applying 3 main stages in this pipeline. First is camera scanner to get the real-time feedback, and then the cropping, and the cropping is smart, whether we need to crop the image or not. And then comes the grid detection parts, applying different filters and getting the right size of the grid, like how many rows and columns are inside the grid. Thank you for watching the video.